If I have some magnesium, and when you just take the metal, we know it's which, monatomic or diatomic? Monatomic. And I'm going to drop it in some hydrochloric acid. Now the metal is going to be solid stuff. You did this in the laboratory. When you were in the laboratory, you could just eyeball it, watch for changes, and make a decision, does it go? Okay, but we're doing paper and pencil. So you have your activity series in front of you, and don't worry about these other parts over here. So what we've got to do, can anybody spot magnesium?
Right, one down.
Right there? Okay, right there is magnesium. If it's going to kick out anything, it would be the hydrogen. Because when you have a compound in this country, positive is 99% of the time or more is written first, and then the negative part. In fact, I can only think of one or two element or compounds that put the positive part first. So we put, or last, excuse me. So we put positive and then negative. So this guy, being a metal, if he becomes charged, he's going to be positive. So if he's going to kick out anybody, he's going to kick out hydrogen. Positive takes the place of a positive. Okay, first of all, the question is, and I have these really in reverse order for single displacement. You got to answer, will it go? Because if it won't go, there's no use taking the time to predict the products. So, based on the activity series, should this go? Yes. Okay, if it goes, then we have to predict products. Hydrogen's going to get kicked out, and what do you know about hydrogen? Monatomic, diatomic? Diatomic. So if you saw this go, you should have seen gas bubbles. Now, your problem now, you have to predict the products, which means you have to write the formulas correctly. That's based on charges. Magnesium, if it takes on a charge, what charge does it take on? Plus 2. How do we know it? By position. All those guys become plus 2. Okay, if chlorine takes on a charge, what charge does it take on? Minus 1. You do your double cross down, disregard signs, that becomes a 1, that becomes a 2.
You always do that? You
Pardon?
always disregard signs?
When you're bringing them down, yeah.
Okay.
Because you don't want positive and negative down here. And in your final product, you don't want the charges showing. This is your rough draft. Okay, so you come up here. What should be my formula based on what we just did? Marco, what should it be?
I think it's going to be MgCl2.
Perfect.
Once you have those two numbers on the bottom, you divide, you subtract your multiplier. What do you?
Okay, you just bring them down. This is the trick.
Yeah.
Is just to bring them down. Here's the thinking way. This is plus 2. This is only minus 1. To balance out charges, it's going to take 2 of these guys to balance out that plus 2 charge, because we need neutral compounds. Here's your checkpoint. Plus 2 times 1 is plus 2. Minus 1 times 2, minus 2. Neutral compound. So you write it like this. Everybody catch, you do not leave the charges in this. After you get the formulas written, you balance the equation. Do formulas first, based on charges. That's set in stone. Then you can do what you have to do to balance. What should we do here to balance this one? Yeah, and that takes care of it. Single displacement. Okay, first, remember I have those in reverse order for your thinking. You ask yourself, will it go? If you decide it's going to go based on that, then you predict your products, get your formulas, then you balance. Let's try another.
You did say that you were going to provide that for the...
Yes, yes. Or I could say, assume this goes, and then all you have to do is predict products. Okay, if we have I have some zinc. Monatomic or diatomic? Monatomic.
I forgot, how do you know if something's monatomic or diatomic?
Okay, I bring clay for our new house.
Okay.
Did that jog your memory? Okay. Now, in your laboratory, when you were doing the single displacements, okay, first of all, you had zinc metal and you had copper, a solution. You had some copper nitrate. Okay, you take a look at this. First off, you have to recognize it has the potential of single displacement, right?
Yeah.
Because it's an element and a compound. After you decide it's going to be a single displacement, then you look up there and you say, will it go? Well, let's see. Zinc. Right there is zinc. Way down here is copper. Will it go?
Yes.
Yes. So we expect it to go. Now, today, for the quiz, I would have as a helpful hint somewhere around that the nitrate, this as a unit, it's a polyatomic ion, acts as a unit. I would say it's a -1. And then down here is a helpful hint. I would say the copper is a +2. And on your data sheet, the one that said write all these equations if they went, up at the top, if you read the fine print, it tells you what the charges are on those ions. Because once you get metals from the B families, they're not predictable. And so copper will be +2. If zinc takes on a charge, it will be +2. Okay, so if I have this helpful little guideline, first of all, you answer the question, what kind? And you said single displacement. And then I say, will it go? And you look up there, yeah, it will go. Okay, but you saw in lab if it would go or not. But you know, there's no law. You can't look in a book and say, did what I see, did it make sense? Okay, so let's predict what we're going to get. What's the metal that gets kicked out?
Copper.
Copper. And you could write it first, you can write it second, it doesn't matter, but it does have to be on the right arrow. Is copper, Meredith, monatomic or diatomic?
It's monatomic.
Monatomic. So you should see some copper-colored metal coming out of that solution, and then zinc, which is +2, nitrate, which acts as a unit, like one thing. You've got to put that together. And even though we have a polyatomic ion, the double cross will work. Okay, Marco, you were asking questions about that. Tell me the formula for zinc nitrate.
That's going to be CnNO3 2.
Perfect. Is it balanced? Yeah, we're balanced just fine. The only one in your lab here that was not +2 for the metals was iron, and I believe it was +3, but it tells you that. So when you're balancing there with the iron, keep in mind if it ends up on the other side, it's going to be +3, not +2. Okay, now let's take a break. So the quiz is going to be over single displacement. Okay? Will it go? I'll have it up there. Okay, we're all set. Assume it goes. Then, you got to be able to take it and predict what your products are.